All right, let's get started with 1-7, absolute value equations and inequalities. So what are we going to learn in 1-7, absolute value equations and inequalities? We are going to solve absolute value equations, and we're going to solve absolute value inequalities. So just one conceptual objective. Absolute value is distance on the number line. So we'll look at that in our first example, and then we'll solve some equations. So definition of absolute value is the absolute value of x equals a, so that x equals negative a or a. So if we do the absolute value of 8, we get 8. If you do the absolute value of negative 8, you get 8. If the absolute value of x equals 8, then what was x? X could either be 8 or negative 8, right? The thing on the inside could have been either positive or negative, and we turned it into a positive. All right, so there's that written as a formula. So if you want to write that down, you certainly can. But let's keep moving here to the distance on a number line. So absolute value is used to find the distance between 2 points on the number line. How far apart are negative 4 and 3? So to find the distance, you're going to subtract. So we could say negative 4 minus 3 and get negative 7. Or you could say 3 minus negative 4 and get 7. Either way, we want to take the absolute value because we don't care if we're going from left to right or right to left. We want to know the distance, and the distance would be 7. Let's try an example. Again, if the absolute value of x is a, then x is either plus or minus a. All right, so solve this equation. What we're going to do is we're going to say x minus 3 either equal to 8 or x minus 3 is equal to negative 8. So let's solve both of these. We'll add 3 and get x equals 5. Or x equals, wow, 8 plus 3 is now 5. X equals 11 or x equals negative 5. Okay. Now graphically, if we wanted to, we could put these on a number line. We're not going to do that really ever other than to give you this example here. The solution we're looking for, x equals 11 or x equals negative 5. All right, your turn. Give it a shot. Hopefully, we wrote x plus 5 equals 7. Or x equals 7. Subtract 5 everywhere. X equals 2 or x equals 12. Okay, let's do it again. Another example. 1 minus 3x equals 7, or 1 minus 3x is equal to negative 7. So just like we normally would, we'll subtract 1 everywhere. We'll get negative 3x is equal to 6, or negative 3x is equal to negative 8. Divide by negative 3 everywhere, x is 2, or x is equal to 8 or 3, because your negatives cancel each other out. Your turn. Give it a shot. 1 plus 2x equals 5, or 1 plus 2x is equal to negative 5. Subtract 1. 2x equals 4, or 2x equals negative 6. So x equals, if we divide by 2, 2 or negative 3. All right, now, if we have a situation where we have multiple absolute values, but they're the same thing on the inside, we can treat that like if we did 2a plus 3a. That's 5a. Same thing going on here. So let's get all of the absolute values on one side first. We'll subtract 2, and add 4, absolute value of x is 1. 4, value minus 1. 2's cancel out. Negative 3 plus 4 is 1. Absolute value of x minus 1. Don't really need the 1 there, but we're going to write it for now. Equals, these cancel out. 7 minus 2 is 5. Now, once all of your absolute values are all by themselves, now we can write it as two equations. X equals 5 or negative 5. So we'll add 1. X equals 6 or x equals negative 4. All right, give it a shot. All right, what are we going to do? We're going to add 3 absolute values of x times 4 to both sides. So those will cancel out. And we'll minus 3 from both sides. So those cancel out. I'll end up with the absolute value of x minus 4 equals 8. X minus 4 equals 8. Or x minus 4 equals -8. Add 4 everywhere. And x equals 12 or -4. Okay, on a problem like this, the answer is pretty straightforward because the absolute value turns things positive. This is saying the absolute value turns something negative. That can't happen. No solution. You go straight to that. You can't have an absolute value equal to a negative. So the answer is no solution immediately. All right, we'll try one more with the quadratic. So 5 minus x squared is equal to 1, or 5 minus x squared is equal to -1. Now, just remember, anytime you have an x squared problem, that means 2 solutions. From both parts, here's 2 more solutions. So we're going to end up with 4 solutions total here. All right, so on this problem, 5 minus x squared is 1. Let's subtract 5. So we're going to get -4. We'll divide by -1. So x squared equals 4. And we'll square root both sides to get x equals, not just 2, but plus or minus 2. Here we'll subtract 5, and we'll get -x squared equals -6. So x squared equals 6. The square root doesn't reduce, so x equals plus or minus add 6. Your turn. 7 minus x squared equals 2, or 7 minus x squared equals -2. Subtract 7 everywhere. So -x squared equals -5, or -x squared equals -9. X squared equals 5. So x equals plus or minus rad 5. X squared equals 9. So x equals plus or minus 3. 4 answers. Okay. All right, so we're going to move on to absolute value inequalities. So we've actually done something very similar to this when we were solving for the intervals on the inequality. All right, so our answers are either going to be in between or on the outside. Now, this is very straightforward to get. If your absolute value is less than, that's the equivalent of saying closer to on the number line. We're going to shade in between. If we say greater than, then that is farther apart. If we are farther apart, we can't be in the middle. We have to be on the outsides. All right. So if the absolute value is greater than, we're always shading the outside. If the absolute value is less than, we're shading the inside. Okay. All right, so let's solve this. We're going to write 3x minus 2 is less than or equal to 7. 3x minus 2, 7 with a negative. Now, remember when we switch from a negative to a positive to a negative, we have to switch inequalities. So we're going to do that here, right? We went from positive 7 to -7, so we went from less than to greater than. Then we'll solve like we normally would. We'll add 2 everywhere. 3x is less than or equal to 9. 3x is greater than or equal to -5. X is less than or equal to 3. X is greater than or equal to -5 over 3. So if we were to graph this, we have -5/3. And this does have an equal sign on it, so we're going to say closed circle. We're going to say 3, so closed circle. So we need to be less than 3, which is this direction. We need to be greater than -5/3, which is this direction. So we're going to be in between, right? Which we could have known from the get-go because this is a less than. Less than is going to be on the inside, right? So to write this in interval notation, we'll say -5/3, comma 3. And I apologize, these need to be brackets. All right, your turn. Oh, the answer's already there. Well, make sure you can get to that answer. So 2x plus 1 is less than 11. 2x plus 1 is greater than -11. subtract 1, subtract 1, 1, 1. 2x is less than 10. 2x is greater than negative 12. X is less than 5. X is greater than negative 6. So we're going to be in between with open circles, negative 6 and 5. So they are in interval notation, negative 6, comma 5. All right, let's do a greater than. 1 minus 2x is greater than 5. 1 minus 2x is less than negative 5. Subtract 1. Negative 2x is greater than 4. Negative 2x is less than negative 6. Divide by negative 2. What happens if you divide by a negative? Switch the inequality. X is greater than becomes x is less than negative 2. And x is less than becomes x is greater than 3. So if we did a number line, negative 2 with an open circle, less than means that way. 3 with an open circle, greater than means that way. So we're going to go negative infinity, negative 2, the union of 3 to infinity. All right, your turn. 5 minus 2x is greater than or equal to 1. 5 minus 2x is less than or equal to negative 1. Subtract 5 everywhere. Negative 2x is greater than or equal to negative 4. Negative 2x is less than negative 6. X is less than or equal to 2. X is greater than or equal to 3. So we're going to be outside of 2 and 3. So we will be negative infinity to 2, union 3 to infinity. All right, solving an inequality involving an absolute value. We need the absolute value to be all by itself first. So on this problem, we're going to subtract 2 first before we make it 2 problems. Negative absolute value of 3x is less than negative 1. And the absolute value is not by itself yet because there's still this negative 1. So we need to divide both sides by negative 1. So the absolute value of 3x is, flip it, greater than positive 1, right? So once it's by itself, if this is a negative over here, the answer is no solution. But in this case, it's 3x is greater than 1, or 3x is less than negative 1. So we'll say x is greater than a third, x is less than negative 1/3. Open circles, shading on the outside, right? Because this was a greater than problem once we got the absolute value by itself. So in interval notation, that's not written there. In interval notation, it's going to be negative infinity, comma negative 1/3, union 1/3. All right, we will see you in class next time.